So for equivalent fractions, what we want to look at is doing the same thing to the top and the bottom of the fraction. Now with fractions, always you have to do the same thing to the top or the numerator of the fraction as you do to the bottom of the fraction, the denominator. Okay, so if we wanted to find an equivalent fraction for this fraction here, 3 over 5, which is 3/5, what we could do is we could multiply or divide the top and the bottom of this fraction by the same number. Okay, so for example, we might find an equivalent fraction for 3/5 by multiplying by, we'll say 2, because it's easier. So if we multiply the top and the bottom by 2, you can see here, I've got 2 times 3, which is 6, over 5 times 2, which is 10. Okay, so what that means is that those two fractions, 3 over 5 and 6 over 10, are actually equivalent fractions. Equivalent means the same. Okay, so it means that they're effectively the same fraction. All we're doing by doing this, okay, is we're making it into a form where it's not what we call simplest form. Okay, now we could do more with this if we wanted to find other equivalent fractions. So for example, again, you might want to maybe times this by 3. Let's find ourselves another equivalent fraction. Okay, 6 times 3 is 18 over 10 times 3, which is 30. So that means another equivalent fraction to the one we started with is 18 over 30. And you can keep doing that. I mean, you could go on forever. Now the other thing, or what I should write down, which is really important, so this is a way of finding equivalent fractions by multiplying. There's only two ways you can do this, either by multiplying or by dividing. So I'll do this one, go back to green. So if we look at this example here, this fraction, 2 over 6, what we're going to do is we're going to divide the top and the bottom by the same number. Now pick a number that doesn't make any of these a decimal. Pick a number that goes nicely into both. So if you look at these two numbers, the number that comes into mind that would divide nicely into both would be 2. So if we divide the top, remember we have to do the same thing to the top and the bottom, divide them both by 2, we're going to get 2 divided by 2, which is 1, and 6 divided by 2, which is 3. So 1/3. So what that means for this new case here is we know that 2 over 6 is the same or equivalent to 1 over 3. And that actually links to simplest form, which we can talk about a bit later on. Now these two down here, oh, again with this one too, I should say that you can't go any further than this by dividing, okay? Because we've got to 1, that's it. And often you'll find you'll get to a point where you can't divide anymore. And when you can't divide anymore, this actually is what we call the simplest form. Doesn't always have to have a 1 on the top. It might just be two numbers that don't divide by anything else. For example, this one here, 3 over 5, that's in simplest form. This one here, 2 over 3, is also in simplest form. So again, the two ways that you can find equivalent fractions is by multiplying or by dividing. And when you do that, you have to make sure that you're doing both of these by the same number on the top and the bottom of the fraction. Okay, so the same number, top and bottom. Always. We always do that with fractions. That just keeps them so that they're still the same fraction. Okay, now it's really useful, equivalent fractions, for when you're comparing two different fractions. When they have different denominators, you can't compare them very easily. But what we can do is we can try and find equivalent fractions that have the same denominator when you're comparing. So for comparing, and I'll do this in red, it's very important. So if you're going to compare two fractions, you really want them to have the same bottom of the fraction, the same denominator. Okay, so if we have a look here, we could find some different equivalent fractions, but the one that would be most useful would be one where we can easily get the bottom of these to be the same number. So just have a think for a second what number you might like to have there as the denominator, and I'll just erase what we've done here. Okay, so if we go back to this example, let's have a think with 3/5 and with 2/3. The easiest way to try and compare them, to get the denominator that's going to work nicely, multiply the denominators together. Okay, so you can see we've got 5 and 3. Okay, 5 times 3 is 15. That's going to be our denominator here, 15. So the way we can get that is we have to keep in mind, okay, I want 15. What do I have to do to the fraction? Okay, to get 15 on the bottom, I would times 5 by 3. That would give me 15. Okay, now because we're doing equivalent fractions, we have to do the same thing to the top as we did to the bottom. So we've now got 9 over 15. And for this one, let's make the bottom 15 as well. Makes them easy to compare. So if we look at the 3, how do we get from the 3 to the 15? We could times by 5. And again, we have to do the same to the top and the bottom. Okay, so we'd have 2 times 5, which is 10, and 3 times 5, which is 15. So what that tells me when we look at both of these now, and we'll draw them out again so you can see, we were originally comparing 3 over 5 and 2/3. And we wanted to find which one was bigger. Okay, we now know what they look like. 3 over 5 is equivalent or the same as 9 over 15. Oops. And 2 over 3 is the same or equivalent to 10 over 15. So looking at these, which one's bigger? And you can see that the one that's bigger is this one here. 10 over 15 is bigger than 9 over 15. So 2/3 is bigger than 3/5. So equivalent fractions are really useful, particularly when you want to compare fractions together.